This video explains yet another resource negotiator, often called YARN, a crucial component for managing resources in Hadoop clusters. YARN efficiently handles resource management and job execution in distributed Hadoop environments. In essence, YARN is the backbone for coordinating tasks across a Hadoop cluster, ensuring resources are allocated effectively and that jobs run smoothly. Let's define what YARN actually is. YARN stands for Yet Another Resource Negotiator. It's a cluster management technology within the Hadoop ecosystem. It distinctly separates resource management from data processing. This separation allows for more efficient and flexible cluster operation. Some of YARN's key capabilities are: first, resource allocation and scheduling, meaning YARN decides how resources are assigned to different jobs. Second, multi-tenant job execution, which allows multiple users and applications to run simultaneously. Third, fault tolerance and recovery, that helps to ensure jobs can recover from failures. And fourth, dynamic resource scaling, that enables resources to be adjusted based on demand. Now let's explore the key architectural components of YARN. There are mainly two components. The first one is the Resource Manager. The Resource Manager is the central authority for resource allocation and scheduling across the entire cluster. Its responsibilities include global resource scheduling, managing the lifecycle of applications, and tracking available cluster resources. The second one is the NodeManager. The NodeManager resides on each node in the cluster and is responsible for managing containers and local resources on that node. It handles container lifecycle management, monitors local resource usage, and reports the health status of the node to the Resource Manager. Now let's discuss the ApplicationMaster and Container. The ApplicationMaster coordinates the execution of an application and negotiates for resources with the Resource Manager. Each application has its own ApplicationMaster. The container represents a basic execution unit in YARN. It is allocated a specific amount of resources, such as CPU and memory, and provides an isolated environment in which to run tasks. Let's walk through the resource allocation process in YARN. First, submit request. The client submits an application to the Resource Manager. Second, launch ApplicationMaster. The Resource Manager then starts the ApplicationMaster for that application. Third, request resources. The ApplicationMaster negotiates with the Resource Manager to request containers for executing tasks. Fourth, execute tasks. Finally, the tasks are executed within the allocated containers on the nodes in the cluster. YARN offers different scheduling policies to manage resource allocation. The first one is first in first out, often called FIFO scheduler. FIFO scheduler processes applications in the order they are submitted, using a simple queue. Second one is capacity scheduler. The capacity scheduler allows for multi-tenant resource sharing by providing guaranteed capacity allocation to different queues. The third one is fair scheduler. The fair scheduler dynamically balances resources between applications to ensure fair allocation across the cluster. Now let's explore resource monitoring and management capabilities in YARN. For resource monitoring, it offers real-time cluster metrics, tracking the health of nodes, monitoring container resource usage, and providing application performance data. And for dynamic management, it includes automatic resource scaling, adjustment of queue capacities, preemption handling, and failover mechanisms. Let's summarize the benefits and common use cases of YARN. Key benefits are: first, improved cluster utilization, meaning YARN makes better use of available resources. Second, multi-tenant resource sharing, that allows multiple users and applications to share the same cluster. Third, scalable job execution, meaning YARN can handle large and complex jobs. Fourth, fault tolerance and recovery, that ensures jobs can recover from failures. Some common use cases are: first, MapReduce processing for batch processing of large datasets. Second, Spark applications for in-memory data processing. Third, stream processing for real-time data analysis. Fourth, machine learning workloads for training and inference tasks. In conclusion, Yarn is the backbone for efficient resource management and coordination across distributed Hadoop clusters. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.